Welcome to Windows Presentation Foundation, Coding WPF with C#. In this brief video, we'll take a look at how C# can be used to build WPF applications. As you undoubtedly know, Extensible Application Markup Language, or XAML, is a declarative language that is the lingua franca of Windows Presentation Foundation. Because it's a markup language, it works particularly well as a target for design tools, such as Microsoft Expression Blend or Visual Studio's Cider Designer. It supports a great many scenarios, including most design time scenarios that you would come across while building WPF applications. However, XAML has some limitations. XAML is not ideal for building user interface controls on the fly. Not that it isn't possible. XAML is XML, and you could generate XML in code and then load the XML dynamically as XAML, but this would be somewhat cumbersome. You also might want to create an arbitrary number of elements, perhaps doing so in a for or a while loop. Or maybe you just want to modify properties or add and remove events dynamically during program execution. There are lots of reasons to become familiar with how code can be used instead of XAML to generate WPF content. Fortunately, anything you can do in XAML, you can do in code. This is because all XAML elements map directly to Common Language Runtime objects, and the attributes of XAML elements map to the properties and events of those objects. So, while it would be somewhat cumbersome to build a WPF application without a trace of XAML, it's certainly possible. Let's take a look at a simple scenario that benefits from using C# as opposed to XAML in order to create WPF objects. Now, I've already created the basic user interface in XAML for the application that I'm going to create. But the issue is that I want to create a photo browser, and my photo browser is going to display images from a folder in a grid. Now, since I'm allowing the user to select the folder, I don't know how many images there are going to be. Maybe there's going to be 4 images, maybe there's going to be 20, or maybe there's going to be 100 images. And I want to show all of the images in the folder, and I want them to be as large as they can be given the available space in the application. So there's a lot of things that are changing sort of dynamically, and for that reason I'm going to use code behind in order to generate the XAML objects that will store and represent the images themselves. So the reason that I wanted to start here in the XAML code is just to point out that the UI is already designed in XAML, and there's a grid that has no contents called photo grid, and that's really for our purposes the only XAML element on the markup side that we're really going to interact with, and everything else we'll do from code behind. So the code behind, there's some code that's already written that has to do with reading from the file system or showing the folder browser dialog. So we'll skip past that, and I'll focus on implementing one specific method called Populate Grid. So Populate Grid, as the name suggests, its job is going to be to take all of the JPEGs in a particular folder that's passed in and display them on that grid that's already in the XAML. So the first thing I'm going to do is I'm going to add or create an image source converter, and I'll actually come back to this later because we're going to use it, but not yet. I'll create a file info array of my pictures, and I'm going to just for demo purposes just focus on JPEGs for now. And this is, part of the dynamic nature of this application is that I don't know how many pictures there are going to be. So I've got a little utility method that's already written called calculate grid size. And if I pass in a number, in this case the number of pictures in the array, then it's going to calculate the minimum grid size that would be able to display all of the pictures. So in the case of 16 images, it's going to return a 4x4 grid. If it's 15 images, it'll still return a 4x4 grid until it gets down to, say, 12 images, and then it'll be 4x3 and so forth. So the math on that's already written. Now we can just focus on actually generating some XAML objects. Now, one of the things that you need to handle if you're dealing with a grid is you need to define the rows and the columns. Since I don't know until runtime how many rows and columns there are going to be, it's not something that I can do in XAML. So I'm going to do it in code behind, and I'll do it by simply doing a for loop, and in that for loop I'll locate the photo grid that's defined in the XAML, and then I'll add a new row definition to its row definitions collection. And I'll do the same thing for columns. Okay, so now what I've done is I've dynamically changed the number of rows and columns in my grid using code behind. Next up, I need to make sure that for each of the cells that is needed, I place one of the images there. So I'm going to have to create the images too. In fact, for the sake of time, I'll go ahead and reuse both of these for loops, because we'll use a nested loop to determine, to be able to go through and identify or pick out each cell. So for each cell, I'm going to go in and grab the next image in the array. And I'm just going to create it using code, because most any WPF object I can create just with a call to its constructors. Right? WPF objects have to have empty argument constructors because remember, most of the time they're getting instantiated based on markup, and so in order for the markup to be able to then get transferred or translated into a CLR object, you can't expect a specific constructor. So in the image, we're going to initialize some of the properties. If we were doing this in XAML, then we'd be using the XML attributes. Here, we just set properties of the object. For purposes that will be obvious a little later, I'm going to make sure that my image has a unique name, and I set that property. This would be equivalent to the name or X name as it's sometimes seen. I also need to set the source. Now in XAML code, you can just set source equals and then you put maybe a location on the disk or something, and then the processor, the parser for XAML, just sort of figures it out. Well, there's actually a method to that, and it uses a string conversion where it analyzes the value as a string and tries to determine what you're trying to get at with respect to the image. Well, that's where the image source converter comes in. Since image source converter is going to give me an object of type simply system.object, I need to do a cast here, and then I'll use my image source converter and I'll convert from string, and this is where I retrieve the full name, including the full path of the picture. Then we'll make a few other minor changes. Let's use stretch.fill property. In XAML, this would look like simply stretch equals fill. Here we use the enumeration margin equals new thickness. So you can imagine what this would look like in XAML code, but anything that we can do in XAML, we can of course do in code as well, including setting the row and column for the grid values. So we're going to set the row using these static methods of the grid object, or the grid class rather, and then finally we'll actually add them to the grid. increment X, and then we need to check to see if we're done, because in the case of say maybe 13 pictures, we'd actually have 16 cells, so we need to break out of the loop. So one way we can do that is just to check to see if we're greater or equal to picture length, and we can do that out of both loops. So at this point, let's go ahead and see what our code has added to our application. When we go ahead and browse, we could see that we can move out and select from our sample pictures in Vista. And we'll see that there's 15 sample pictures, and they all appear in our application. So it generated a 4x4 grid based on 15 pictures, and now because it's a grid, I can expand and contract, and because of the grid behavior and the fact that how I've configured the images, they're just going to go ahead and expand and contract as we go. Alright, what else can I do in code behind? Well, actually quite a bit. For purpose of demonstration and also for purpose of saving time, I'm going to paste in some code, and then we'll talk a little bit about it. I can actually define animations completely in code behind, and so for instance here I'm defining a couple double animations that target opacity of the images, and those each animation, one that goes to opacity 0.6 and one that goes to opacity 1.0. Each of them are associated with a storyboard. Each storyboard then gets a name that's associated with the image, and the images we're going to register events. So again, if we were defining an image in XAML, well, then we could use the mouse enter attribute, and we could use it to map a to an event handler in the code behind. In this case, we're generating the image objects on the fly, and so if we want them to have events associated with them, well, we need to add those events in the code behind. And here we're doing it for, you know, every single image that that we want to place out there. So we actually need to call this method add animation. So we'll do it right after we create the image. And now, just to show a different set of pictures, let's select from this toucan directory, and we can see that we've got a different number of pictures, but it still creates the grid. So this time we have a 5x5 grid, and again the behavior works as expected, only now we've got an image animation where each individual image fades in and out based on the mouse movements. So this is just one example, or a few examples of situations in which code can be used in order to build a WPF application and really address scenarios that would be very difficult, if not impossible, using XAML alone.